So I am Rob Howard from East Carolina University. I'll be the moderator for this session. I have the pleasure of moderating a session that has several Herb Stout Student Award winners in it. So today we'll be hearing from Tanisha King from Fayetteville State University, Sarah Riddell from East Carolina University, and Catherine Sharon from East Carolina University on various topics. It all looks fascinating. So I shall hand it over to Tanisha to get us started.
Thank you, Robin. Sorry, it keeps switching over. Just going to try and position this. I have a little voice, so I want to make sure everybody hears me. Can everybody hear me okay? Perfect. Okay, so my name is Tanisha King. I am a graduate from Fayetteville State University. I work with the Geospectral Department with my professor over here. Stand up, Mr. Professor Tran. That's right, stand up. Come on. He embarrassed me last time, so I had to get him back. And we worked on this project together. Okay, and we are exploring the relationship between the spectral distribution on solar PV rays and socioeconomic factors in the Eastern Carolinas. The central roles of solar energy is a growing population and analyzing demographics and sustainability. The reason why we're doing this research is because we're trying to help people understand the reason why solar energy would be a good thing for socioeconomics and sustainability for people generally in the Eastern Carolinas. And I gave a few instructions here on the reasons why we think this would be beneficial for everybody. One is the importance of researching the relationship between solar energy and the demographics and socioeconomics. That is, the growing population, which leads to the increase of energy demand. As the population grows, so does the demand for energy. You know, we all have our needs. Some people use a little more energy than others. Some are a little bit more responsible. Some are a little more conservative. So we need to understand the energy that we're putting forth and being responsible when we're doing it. Limited natural resources raise concerns about environmental, economic, and sustainability issues. While we're using the environment, we're not able to go back and put it back in. So as I explain to people, once it's used, it's gone. That's basically what we're saying. So having renewable energy is the only way we're going to be able to sustain ourselves for future benefits. Again, we're going back to renewable energy sources are critical for achieving energy that is sustainable. Sustainable is something that we can keep using. That is what renewable energy is. We want something that can be replicated, something that can be reused over and over without any type of efforts that will interfere with any type of environments, harmful to anybody else, and cause any issues where it can also interfere with other aspects of things like politics, because we all know how that lovely aspect gets hit with a lot. The other thing we're going to come back with is the characteristics of effective renewable energy sources. What they're saying on this side is these are the characteristics that make it effective and renewable for energy sources, meaning it has to be replicated, has to be something that can be done easily, it has to be affordable. It has to be socially accepted. When I mean socially accepted is, it's just not something where the communities have to look at it, it's something where people in the politics have to look at it, and then we're also gonna have something that's well understood. We just don't wanna put it out and say this is what is best for everybody, but we wanna make sure everybody understands why, how it works, and why this should be a good idea for everyone. And then go to the next slide. We're going to be unlocking a sustainable future and the central role of solar energy. So my image here is just basically showing all our past futures, and I'm just going from non-renewable to renewable energy. And then I'm going to go down a slide here. Reduces green gases, emissions, pollution while preserving habitats, decreasing reliance on fossil fuels, positions North Carolina counties as leaders in renewable energy, shaping climate policies, and promoting carbon neutrality, and lowers health risk from pollution and fosters cleaner communities. One thing that's really affecting the growth of sustainability is politics really don't like the idea of putting out money unless they have some kind of data showing that this is really going to be beneficial. And one thing that really tends to be hit is the health. They don't like putting a lot of data and money towards health because that tends to really cost a lot of money. And if they can save money when you're showing that health, and that's what's really taking up funding, they tend to be a little more lenient and looking at other prospects for that kind of thing. The next thing we do is create jobs in the renewable sector. Lower energy costs attracts investments in green technologies. So we're opening up a field where people can actually grow and earn income. So it's generally, people will come in, get educated, go to their communities, and basically they can teach their children and future generations on how to sustain themselves by fixing the technology, thus prospering economically and solary-wise. The next thing we're going to talk about is provides reliable energy sources that adapt to climate impacts, supporting local systems during the extreme weather. So we're going to try and provide reliable energy sources that can adapt to all kinds of climates. So we want to do solar energy that can weather all kinds of hazardous natural disasters that come on, because we all know North Carolina has the best weather. So we want to make sure that no matter where we put these solar energies, they're capable of sustaining themselves and being rebuilt back up if it needs to be without costing so much. So here are a few programs that North Carolina has in the eastern side of it. So one program that is growing is the solar rebate program. This program helps make rooftop solar energy more accessible in North Carolina, only in North Carolina so far. I know it says that it's the eastern North Carolinas. We do the whole eastern Carolinas. That means north and south. But so far, North Carolina is the only one that has a lot of the solar programs. South Carolina is not really advancing too much in these programs. They do have some, but North Carolina is the one that's leading so far. We want to go and hear some more. It is created by the North Carolina Sustainable Energy Association and Duke Energy and was created in 2017. It offers rebates for 20 megawatts of installations each year for 5 years. The Energize NC program supports low-income and disadvantaged communities in North Carolina by installing rooftop solar panels and offering community solar options. The program will gather feedback, train individuals from minority communities, and provide financial initiatives for solar in homes and multifamily housing. This program generally is going to go for a year. It just got approved 2024, and it's going to go in sometime in 2025. It has not started yet, but the whole goal is to improve low-income families, get them trained where they can, of course, earn money, but also get their feedback into why they think this will either help or won't help, and if they're willing to continue the program if funding is available. Here are some of our research questions. What is the spectral distribution of solar PV installations in the Eastern Carolinas? How does PV installations relate to the regions of socioeconomic characteristics? So here is our study area. As I described earlier, we're focusing on the Eastern Carolinas. Again, that is the North and South Carolinas. Altogether, we have about 65 counties east of I-95. Again, that is going from the North and South Carolina. There are 17 urban counties and 48 rural counties. We're looking at the socioeconomic of 2024. The average population is 86. That's urban. It's going to be about 22, I have glasses on, I still can't see, 221,000. 835, and the rural is going to be 46,268. There we go. That's my problem. Average medium age is about 44. Urban is 40. The rural is 46. The average household income is about 57,758. Urban is 67,553. Rural is 54,290. We're going to go down to our education, which is an average of 25 plus, meaning we're going to 25 and up. With bachelor's degree, that's 12,844 all total. And you're going to be looking at an urban with 33,561, rural 5,507. You're going to look at the average in the second half, that's 25 plus with graduate's degree. That's about a total of 7,589. Urban has about 20,134, rural 3,146. The number of large-scale solar photovoltaic facilities is a total of 473. Urban has 86, rural has 387. The average is 7, and urban has about 5, rural 8. Mine's just blurred over here. Hold on 1 minute, guys. I apologize. So here are the, I fixed it. Okay. Here's some methodology we did. So we generate maps on solar, scale polar, photovoltaic facilities, and socioeconomic factors. Visualize comparative spectral patterns of large-scale polar photovoltaic facilities and socioeconomic factors. Explore the correlation between large-scale solar photovoltaic facilities and demographic socioeconomic factors using scatter plots. I talk really fast, and so if you guys are having a hard time, raise your hand. Or if you can't hear me, raise your hand. Okay? Don't be shy. Spectral distribution of large-scale solar photovoltaic facilities. So the large-scale solar photovoltaic PV facilities are thriving in eastern North Carolina. The highest concentration of these facilities are located inland, particularly in the northwestern areas of eastern Carolina. In comparison, the eastern region of the South Carolina has fewer smaller solar scales PV facilities, generally ranging from 0 to 1 or 2 to 4. These are megawatts. This is what they're producing. As a result, South Carolina has a lower overall number of large-scale solar PV facilities compared to North Carolina. Okay, so we're going to go into my slide. In our large-scale solar photovoltaic facilities versus the population density. Distribution of population density. Values range from 3.2 to 1,086.2 with a mean of 134.06. The data has a high standard deviation of 169.5, indicating that the values are widely separated and spread. So you can see how they're spread out. Distribution of large-scale solar facilities. The number of large-scale solar photovoltaic facilities range from 0 to 40 with a mean of 7.28. Again, remember this is the megawatts. A significant number of counties have 0 facilities, with a few, while a few have much higher counts. Correlation between the population density and number of solar facilities. The Pearson correlation coefficient is 0.0054, indicating that there is no significant correlation between the population density and the number of solar facilities. And I'm going to come back to that and explain that in a bit as well. So we're coming out on time. Solar scale, solar photovoltaic facilities versus medium age. Distribution of medium age. The medium age ranges from 29.8 to 54.1 with an average of 44.16. Data has a standard deviation of 5.12, suggesting a moderate spread. Correlation between the medium age and number of solar facilities. The Pearson correlation coefficient is a negative 0.25, indicating a weak negative correlation. This suggests that the areas with lower medium age tend to have slightly more solar facilities, but the relationship is not strong. Discussing, younger populations may be located in areas that are more suitable for large-scale solar farms, such as rural or suburban areas with more open land. Older populations may be more concentrated in urban or historical communities where large-scale solar development is more restricted. Large-scale solar photovoltaic facilities versus household income. Distribution of medium household income. The income ranges from $31,938 to $91,550, with an average of $57,759. The data has a standard deviation of 15,013, indicating a moderately wide spread. So again, we're seeing generally a lot of spreading in my plot sheets. Correlation between the median household income and number of solar facilities. The Pearson correlation coefficient is a negative 15, that's indicating that very weak negative correlation. This suggests that areas with higher household incomes tend to have slightly fewer solar facilities, but the relationship is not strong. Discussion, the lower income areas may be more rural with more available land for large-scale solar installations. Higher income areas may be more urbanized, where large-scale solar farms are more feasible due to land constraints. How much did you say, 1 minute? 5 minutes? Okay. Next, we're going to go into our next slide, down for time. So, distributions of bachelor's, this is about just education. Degree holders, this is 25 and up. The number of people aged 25 and up with a bachelor's degree varies widely from 203 to 96,181, with a mean of 12,844 people. The data has a high standard deviation, and with about 18,665, indicating a large spread. The correlation between education levels and the number of solar facilities, again, we're seeing the correlation is a negative. It's about 0.11, indicating very weak negative correlations, suggesting that the areas with high numbers of bachelor's degree holders tend to have slightly fewer solar panels in facilities, but the relationship is still weak. And I know you have a question like, why are you showing data where it's mostly negative? And I'm going to get to that in a bit when we do some questions. We're going to continue on with a little bit more education. This is at a graduate level. The number of people with age 25 and up with a graduate degree or professional degree varies widely, ranging from 105 to 63,309, with a mean of 7,589. The standard deviation is 12,131, indicates a high spread, meaning that some areas have slightly more educated individuals than others. Now we're going to look at the correlation between the graduates, professional degree holders, and the solar facilities. Again, we're looking at the correlation coefficient, and it's in a negative, 0.17, indicating a weak negative correlation. This suggests that the areas with higher numbers of graduate degrees tend to slightly hold fewer solar facilities, but again, their relationship is still low, and it's still weak. Discussions, areas with higher education levels might be urbanized, making large-scale solar projects less feasible due to land constraints. More educated populations may focus on rooftop solar, more energy efficiency, or other clean energy solutions, reducing the need for large-scale solar farms. Go into a new one, distribution of median home value. So this value ranges from about 71,228 to about 540,000 to 358, with an average of 220,000 to 236. The standard deviation is about 98,936, indicating a wide spread of home values across different locations. The correlation between the median home value and solar facilities, again, that correlation is a negative, sadly, and that is a 0.27, indicating a negative correlation, suggesting that areas with higher home values tend to have slightly fewer solar facilities, but the relationship is not very strong. Urban versus rural factor areas with higher home values may be more urbanized, where large-scale solar farms are less feasible due to land constraints. The conclusion and future research. So there are correlations, even though not very strong, between the number of large-scale solar facilities and demographics, as well as socioeconomic factors as population density, median age, median household income, education attainment, major appliance expenses, and median home value. Other factors such as land use, state policies, and energy infrastructures may play a large role in determining solar facility placement. Future research is to incorporate land zoning regulations, state-level initiatives, and urbanization levels into research. Conclusion and future research, there are correlations, even though not very strong, between the number of large-scale solar facilities and demographic, as well as socioeconomic features such as population density, median age, median household income, education attainment, major appliance expenses, other factors such as land uses, state policies, energy structures, might play a larger role in determining solar facility placement, while diversity may play a role. Other factors such as land availability, state policies, solar initiatives, and economic conditions may also affecting the distribution of solar facilities. Again, we're going to incorporate land zoning regulations, state level initiatives, and urbanization levels into research.